What's up guys, Blank here. Today we are going to talk about the history and the evolution of how does actually AI and systems like this work. Uh, this was a very interesting topic for me because I really think that not a lot of people understand the history of how we came here and what are the different workflows and tools that people use to make sense of all these things. So, uh, today we're going to talk about this paper from Versal called Testing If Bash is All You Need. It's a study on if Bash is basically the only thing that a model requires to execute something. And it is very interesting, but before that we have to understand how did we actually get here. So I came up with this ingenious way of explaining it. So here we go. If you remember back in the day, we had ChatGPT, and in ChatGPT, all we could do is give some input and some context, and ChatGPT could convert it into output tokens. Basically, the idea being that this big LLM model could look at the input to context and tokens and predict the next tokens, and that's all it could do. And yeah, it was impressive at its time, but it wasn't the most efficient way of doing something. We needed a way to explain to a model a lot of other things, and OpenAI knew this, so it developed a lot more understanding and updated its API to support a few more things. And what it did was basically have three type of prompts. One is the system prompt, which is basically like an overall prompt about the system. So that is like, for example, you are being a helpful assistant for a country, or you are being a helpful assistant for an organization, with some context on what to do and what not to do. But this was also prone to some hallucinations. As you can see here, we had system prompt, context, and the query, as well as the previous chats as well. Basically, the idea being that the model could remember the previous chats because it was sent in the next context window. And yeah, that did cost a lot more tokens, because with every single token that a model has outputted, it was reinserted into the context window, and that clogged the system really bit. So the next thing we did to mitigate that was to insert something called a vector database. A vector database like a VV8 or Pinecone was all the hype back in the day. And all they did was basically, on the basis of the context, gave you a document or a resource that you could feed to the model. The idea being that your input could be the key to get some output context to the model. And that idea blew off. Many companies became overnight successes over this, and it was really insane looking at all the RAG systems people built. But we very quickly realized that maybe this wasn't the best way of doing something. Maybe model could ask for multiple resources or multiple sources of information, or for example, we do not let the humans compute the input and everything, and let the model determine what it needed at the same time. And you can see that even in this system, everything else is same. All we had was this vector database column where we ingested some data, we put some input, and based on an input we got a document that was the most similar document based on the context and everything. And that was basically how we built all the rack systems and everything, but that did not work really well. So we moved on to a very new system. And if you remember, DeepSeek was one of the first thinking models. By the way, fun fact, model does not need to do the thinking in English, it just does, and it's just its behavior. We are very lucky to see its thinking tokens. uh, and basically why that is because of this loop here. So this is what we call as a thinking model. So basically the idea being that the model would go outside, implement something, right? And based on that implementation, it would think to itself, meaning it would understand and talk to itself. It could reprompt itself continuously until it got through something and implemented something successfully. And that was also a very big achievement, and I feel that it took us ahead. And but yeah, that did mean that we are gonna have a significantly more cost for a thinking model than a regular model, because it had this loop which made the system more expensive to host and more expensive to run. That's why we had like a different types of model in this era. If you remember, we had thinking variants of a model and non-thinking variants of this model, and all it the difference was basically that the non-thinking ones could not create these loops, but the thinking ones could. uh, and this thinking really took off, where we re-implemented this thinking with basically this kind of loop here, where the output went to a thinking state, but we wanted the model to, if it's thinking, we need to dynamically give it some tools, right? This was when MCP came in the picture. The idea being that the model could call this MCP servers, and this MCP servers could basically return them a resource or return them some information about the outside systems, and it could execute some queries. It could run some uh, run some bash commands and stuff like that. Very interestingly, that's what we did. We use MCPs for mostly giving model the outside look into the world and outside look into the various systems that it had access to. If you remember, we had like uh, Claude 4 Claude 4 Sonnet and Claude GPT-5 excelling in these states with MCPs, and Google Gemini 3 also came in the same category of this system. Basically, the idea being that we are gonna give the MCP tool list here, and uh, it's gonna go into a thinking loop and call the MCP servers on its own, and then it's gonna implement it. All it did for calling this MCP server is basically provide a string, and that if that string matches to a key string in an MCP value, for example, say the MCP key string was hello, and if the model said just hello, then it would call that MCP, get the executed output to the thinking model's context in the next prompt, basically. And that's all it did. uh, but you can see that maybe having all these MCP tools was also a big problem because of the context poisoning. Context poisoning is the idea that, hey, maybe we do not need 85,000 MCP tools uh, in our context here. Maybe that could also diminish the quality of resources. If there was a way where we could dynamically choose which MCP servers to add to the context, that would have been amazing. But and yeah, many companies also implemented something similar. Also, Cloud also found that maybe there was a way to do that. Cloudflare also found MCP tool to call the Python code to do something, but none of those worked pretty well, which is where we end up today. Is basically this system here. It's very similar to the last system where we also had the MCP servers, but there was this dynamically learning thing called skills. The idea of skill is basically like, say a model like Cloud Code or GPT 5.2 could basically look into a folder. It could see what other MD files are inside that folder, and based on it, determine which file did it want to read. Idea being that maybe it could list out all the skills that it had, and based on that, it could understand the context of building a front end or building a back end. And you can see that there are many skills. So for example, if you go to skills.sh, you can see that there's an array of all these amazing skills. And yeah, mostly people use this to uh, dynamically set the context of something that they were making, you know. Some of my favorite skills include the Anthropic skills front end design. It was a really good skill where Anthropic really gave an idea on what to build and how not to build something. So, for example, here you can see never use generic AI generated aesthetics, and that was amazing. It really did impact the model a lot. Uh, so, if dynamically learning was happening, we still had MCP tools for executing the code, and that was where we were having the biggest bottleneck till now, where we realized maybe MCPs are not the best way of doing it, because we still had to give MCPs the context here, and maybe we could basically get it out of the system because we wanted the context to be as free as possible for model to have as less input tokens as possible, because that allowed model to freely think and freely do its stuff as efficiently as possible. Also, it made the model cheaper to run. So yeah, we basically found out that maybe bash is the way of doing that, because models already understood how bash worked, and models already understood how all these other Linux tools worked. So we decided maybe Bash is the way to go, and yeah, it was things like Cloud Code, Open Code, uh, Moltbot. Moltbot is now changed to OpenClaw, but yeah, you get the idea. uh, all these tools basically found that using bash as the execution environment really makes sense. So for example, instead of looking through uh, an array of JSON files, right? For example, if MCP tools returned an array of JSON files, we do not need to see all the array. We need to see only a part of that array. So a model could just basically use something like JQ or grep, you know, JQ or grep over the result of an MCP server model, MCP solution, or basically not use MCP at all, implement it on its own. So that was the idea, and it really worked pretty well. But now we are at a point to understand that maybe that wasn't the best way. Versal says that it's not the best way, but I have heard from folks at Pi as well as uh, OpenClaw to say that Bash is the way to go, because ju- Bash really is baked into the models. Basically, it does not need another execution context. It does not need more learnings to do. So, yeah. So let's continue with this paper here. Testing if Bash is all you need. We invited Ankur Goel from BrainTrust to show how they tested the Bash is all you need hypothesis for AI agents. There's a growing conviction in AI community that the file system and Bash are the optimal abstraction for AI layers. That's what we talked about. Maybe Bash is the way to conjoin the execution as well as learning into the AI model. The perfect marriage of already understanding and using the tools that are given to us. Looks like the file systems are the next best thing in AI. This happened because the models are trained heavily on coding tasks. Yeah, exactly. Even non-coding agents may benefit from this approach versus recent building agents with file system and Bash showed by mapping sales calls, support tickets and stuff. Yeah, Bash is really well with all this stuff. So basically everything that you could do over an API or something could you could do in Bash because of core and other similar projects. Um, File system may be the right abstraction for exploring and retrieving context. But what about querying structured data? So in this case, they are talking about the skills, but for this case, they are talking about the bash that we talked. You know, setting up the eval. We task the agents from querying the dataset of GitHub issues, PRs, and semi-structured data mirrors real-world use cases like customer support tickets and sales call transcripts. The question complexity range from simple queries, how many open issues, method security, complex queries, and like so. Basically, what they did was setting up an eval for testing. Hey, how does a model with Bash could do fare against questions like this? And three agents approaches competed with SQL agents, Bash agents, and file system. So basically, if you see this just Bash, I think the CTO of CTO of Vercel basically made Bash in TypeScript. So we are running Bash on natively on top of Chromium now. This is insane, but this was just for a very nicely testing things. But this also validates the point that maybe Bash is the way to go, because why then go out of your way of making Bash in TypeScript? I don't know. So basically now if we see the scores, you can see that SQL gave an accuracy of 100%, average tokens of 155, 531, and cost of 0.5 and took 0.5 seconds. Bash 5.27. SQL dominated, it hit 100% accuracy, while Bash achieves 53%. Bash also used 7% more tokens while taking longer. If you see, explore the SQL experiment, Bash experiment, file system experiment. The surprising finding was that Bash agents was highly sophisticated shell commands. Yeah, that's what I said. Maybe bash bash is useful for like piping various systems together. That's why it is used. But SQL is just the chat of doing pipes or chat of retrieving or executing commands. So yeah, it would work because it was made to do that. Bash was made as a generalized CLI tool, you know. it was generalized everywhere. That's why bash may not be the best way of doing it. Maybe SQL is, but SQL is not the interface that every single tool in history uses. So that's why we cannot use SQL. So I don't know why SQL is in this picture, but yeah, that just makes sense that SQL is really well with retrieving and executing some, you know, temporary questions like this. How many issues and find how what issues. So it's like point lookups and stuff. SQL is really good. I kinda disagree with this results here, but honestly, I think Vercel is what Vercel understands what they're doing. Uh, Maybe yeah, Bash may not be the best way of doing it. Maybe SQL is. But you tell me, how are you gonna use SQL queries to execute a command in curl or something? Because I have no idea how you wipe code that. So yeah, maybe yeah, the hybrid approach I still think is the best one of doing it. And if you want to, you can continue reading this paper. The idea was very simple, that maybe a hybrid approach of SQL, Bash, and file system might just be the way of uh, making an execution environment for a LLM. So yeah, that's where we have like stuff like OpenClaw, which was forked from PyPy, and um, I think Pi went to Syntax channel as well. If you want to check it out, you can check it out there. So yeah, that's where we are left today. And yeah, please check out Just Bash as well. And if you want to continue uh, getting into deep dives like this, please let me know more into the topics. What else do you want to know? All right, thank you so much. I'll see you in the next video. Peace.